So from this video, I will be explaining uh, the algorithm for classification that is called as the logistic regression. And in this video, I will be developing very preliminary knowledge that is required to understand the logistic regression technique. So before starting the discussion of the logistic regression, let us review what we have seen in the previous video. In the previous video, I explained that in case of the classification problems, the output or the dependent variable is always categorical or non-numeric or a qualitative one. The second important point that we discussed in the previous video was that linear regression technique, which is commonly used for predicting numeric value, fails to be adopted for classification problems. And there are numerous reasons are for a non-adoption of a linear regression technique in case of the classification problem. And we discussed all those reasons in the previous videos. And also we saw that there are two kinds of classification problems are there. One is called as the binary classification, in which the output variable y has only two values. And in case of the multi-class classification problems, the output variable y has more than two values. And the technique that the first technique of classification that we are going to discuss is called as the logistic regression technique, and it is basically or widely used for binary classification problems in which output variable y or the dependent variable has only two values. So for that purpose the logistic regression technique is used. So to explain the logistic regression technique, I will be using a data set called coronary heart disease and age related data set. This data set is called as the CHD age data set, and I am uploading the .csv file of this data set. The coronary heart disease is a type of heart disease in which the blood flow to the heart gets reduced. And it has been observed that there is a strong correlationship is present between the coronary heart disease and the age. And we are trying to predict or trying to classify the person, whether the person suffers from a coronary heart disease or not, based upon his or her age. And in this particular data set, there are total 100 observations are there, and these 100 observations I have included on these two slides, and on these slides I have included only two information, that is called as the age and the CHD. Here the CHD stands for coronary heart disease, and if the CHD has the value 0, means that that particular person does not suffer from the CHD disease, CHD or the coronary heart disease. And if the value of the CHD is equal to 1, it means that the person is suffering from the coronary heart disease. And here, for example, this one particular instance of a person who is 20 years old is not suffering from the coronary heart disease. And on this slide, I have included a table in which in each row I have included 4 different records. So this is the first record, this is the second record, this is the third record, and this is the fourth record. And each record is separated by double lines, double vertical lines. And on each row there are 4 records are there, and like this there are 25 rows are there. So 25 multiplied by 4, which is equal to 100. So 100 records are there. I am uploading the CSV file of this data set on our web portal. So this is about the data set that I am going to use to explain the working of the logistic regression technique. And see, now this is the data set, and if we plot a scatter plot of the age is our independent variable, and CHD is our dependent variable. The dependent variable or the CHD takes only two values, 0 and 1. It means that 0 means the person is not suffering from the CHD, and 1 means the person is suffering from the CHD. And independent variable, that is the age, is taking the values from 20 years old to 69 years old. So this is the range of the uh, independent variable, 20 to 69 years old. Now on this data set, what I did is that uh, while reading this data set, we should read the data set in this way. So this is the first record, this is second record, this is third record, this is fourth record. So this is the first record, this is the second record, this is the third record, this is the fourth record, and so on. Then on the fifth record starts on the second row, then fifth, sixth, seventh, eighth on the second row, then next records continue. So this is the way in which you can read the data set. And the records are arranged according to the increasing age, means 20 comes first, 23, 24, 25, 25, and for one particular age there may be more than one records are there. For example, age 25 has two records, whereas for example, if you take the age 35, there how many records are there? 35 is 35 second, so two records are there for 35. For 36, there how many records are there? 36 1, 36 2, 36 3, three records are there. Like this, for one particular age group, there are more than one records are present in this data set. So this is about the data set, and when we plot this data set on a scatter plot, we get the scatter plot like this. So this is the scatter plot that we get. On the x-axis we have taken the independent variable. On the y-axis we have taken the CHD, or that is our dependent variable or the output variable. And if you observe that, so these are the records. Suppose that, for example, the person with the age 20 is not suffering from the CHD, whereas the person, suppose this is the 25th person is suffering from the CHD, and that's why its value is 1, its value is 0. And by looking at the this scatter plot, it is very difficult to establish a relationship, either like linear relationship between age and CHD, and that's why the this way of representing the mapping or the function between the age and CHD does not help us to identify how these CHD and age are related with each other. So in order to establish the relationship in between those, what I am going to do is that I am going to group the age groups like 20 to 29. How many entries are there for in the range between the 20 to 29? There are I think there are 10, 20 to 29. So 20 is present here and 29 is present here. So on one row there are four records are there, on another row there are four records are there, and on the third row there are two records are there. So number of records are 10 here. So in the age group 20 to 29, there are 10 records are there, and out of these 10 records there is only one person is suffering from the CHD. So one is suffering from the CHD, and nine persons are not suffering from the CHD. And if we divide 1 by 10, then we get the probability of the number of persons that are suffering the CHD in a particular group, that we are calling it as 20 to 29, and this value comes to be around 0.01, and this value is called as the conditional mean or C mean, or sometimes it is called as the expected value, or only probability. So again, I am explaining here in this way. In the age group between the 20 to 29, there are 10 entries are there in our data set. On the first four entries on the first row, say four entries on the second row, and on the third row there are two entries are there, which falls in the age group 20 to 29. And out of this train, only one person is suffering from the CHD and nine persons are not suffering. So that's why the probability of person suffering with CHD in the age group 20 to 29 are how many? 0.01. So I am included this value here. So there in the 20 to 29 age group, there are 10 number of persons are there. 9 persons are not suffering from the CHD, for which the value of CHD is 0, and one person is suffering from the CHD, for which the value of CHD is 1. So 9 plus 1 becomes equal to 12. And when we divide 1 by 10, we get this value, and this value is known as the conditional mean or probability. Now, similarly, if you count the number of people or number of persons that are present in the age group 30 to 34, so you may get the 15 number of persons in the age group 30 to 34. So here the number of person you can check like this. So here in the age group 30 to 34. So in this age there are two entries are there. So here 30 30, here four entries are there. Then here again four entries are there. Then again 34 four entries are there, and on this there is one entry is there. So 4 plus 4 plus 4 12 plus 2, this becomes the 15 entries are there. And out of these 15 entries, how many entries has the number of values CHD equal to 1? So on this there is no person, here there is one person, and here there is no person, here there is two persons, one person, and here there is nothing, no. So there are two persons are suffering from the CHD. So here C, the in the age group 30 to 34, two persons are suffering from the CHD, and 13 are not suffering, and 15 people are there in the age group 30 to 34. So the when in the age group only two persons are suffering, and 15 persons out of 15. So that is the probability of the person suffering from the CHD in the age group 30 to 34 is 2 divided by 15. So this is the probability. So this is the way in which you can calculate probability or the expected value or the conditional mean. So the value of this is 2 divided by 15 comes to be around 1.33. Similarly, I have calculated for 35 to 39, there are 12 people persons are there, and out of 12, 3 persons are suffering, and the conditional means comes to be around 0.250. So here on this slide, we have introduced one of the most important concept in order to understand the logistic regression, that we call it as the conditional mean or the expected value or the probability. So, and I have demonstrated how to calculate the conditional mean or the probability or the expected value. Now, this is one of the very important concept that is useful in order to build the logistic regression model. Now, the second point that is very most important to understand the working of the logistic regression is that when we plot a graph of the age group on the x-axis, now in this particular case age group, or in general the x value, that is the input variable, and the conditional probability of the output variable, the conditional probability, this conditional probability of the output variable, this is the conditional probability of the output variable, and this is the input variable in general. In this particular case, this is the age group and this is the conditional probability for CHD. And when we plot this graph on a graph, this graph is like the shape of the graph is like this. Uh, when when it approaches to the zero, it is gradually approaching to the zero, and it is gradually approaching, slowly approaching to the one. But it is a very small change in the in between that, a very small change in the value of x. There is a large change in the value of y. So this kind of graph has a shape of elongated ears. Means the nature of this graph is called as the elongated ears. You see, this is the ear-shaped graph, and this ear-shaped graph can be represented with a function called sigmoid function. And this the sigmoid function has the formula of like this: f of z equal to 1 divided by 1 plus e to the power of minus z. So this is the graph or sigmoid function, and this sigmoid function, the nature of the graph between the when we plot a input variable and the probability of the output variable, then the nature of the graph is elongated yes, or the which can be represented through the sigmoid function. And another important thing that you should observe here is that the value of the conditional mean, or the probability, or the expected value is always in between the 0 and 1. It is never less than 0, and it is never higher than 1. So it is always lies in between the 0 and 1. And the relationship between the conditional probability of output variable and the input variable is similar to the sigmoid function. And you get the many kind of sigmoid functions like this. See, the we have seen that um, equation of the line is y equal to mx plus c. Now the equation of the sigmoid function is f of x or y equal to 1 divided by 1 plus e to the power of minus z. And if you plot a graph, you get many such kinds of lines with different slopes. So similarly, there are different sigmoid curves are there whose value depends upon the value of z, and you get many sigmoid curve. But the nature of the sigmoid curve does not change. It is like this. So elongated S shape. So these are the points with respect to the sigmoid function. Now, the important concept that we have defined in this video is the conditional mean of xi, which is nothing but the independent variable, is defined as the number of xi for which y of xi equal to 1. So in case of 20 to 29 age group, the number of y of xi, the number of ones that are present for the CHD equal to 1 is only 1, and total number of xy was 10, and that's why the probability or conditional mean is 0.1 or 0.1. This is the way in which you can define the conditional mean or the expected value. So the conditional mean of xi is denoted as there are very number of ways in which you can use, number of notations you can use to denote the conditional mean of xi. One way is writing E of y bar x, and it is read like this: the expected value of y given the value of x. Or sometimes it is also represented with this notation, which is read like this: probability of y equal to 1 given the value of x. Or sometimes it is also written like this and read in the same way: the probability of y equal to 1 given the value of x. With the difference is your pr is written, here only p is written. So normally there are three different notations that can be used to denote the conditional mean. So in this video, we have defined the one of the most important concept that is called as the conditional mean or the expected value of the output variable for a given input variable, which is always in the range in between 0 to 1, and that is denoted like the value of expected value is always present in between the 0 and 1. And the relationship between the conditional mean or the expected value of a output variable and the input variable can be represented through a sigmoid function whose graph is like this. And this sigmoid function, this graph is denoted by this equation g of z equal to reciprocal of 1 plus e to the power of minus z, and this value is always in the range between 0 to 1 for different values of whatever the value of x. So these are the two important concepts that we are going to use to develop the logistic regression technique for binary classification. Thank you.